Hey there, welcome back to the channel. In today's video, we'll focus on the binary search algorithm. I think this is probably the most classic searching algorithm used on an array or a list in Python. So what is a binary search? The idea of a binary search is basically to narrow down the searching range. We do this by guessing the middle element within the range, and if the target is larger than the middle element, we'll move the lower bound to the middle. Or if the target is actually smaller than the middle element, we'll move the higher bound to the middle instead. After that, we basically repeat the same process until we find the target. If the range is 0 and the target has yet to be found, it basically means that the element is not in the array. I feel like I just explained the algorithm, but let's just write it down in a human language once again before we try coding this up. So first we need to get the middle element. Then we check if the middle element is the target. If it is, then we return the middle index. If that's not the case, we check if the middle element is larger than the target. If it is, we're going to do a binary search using the middle as the lower bound and the current high. Then, if it's not equals or larger than the target, it is smaller. Therefore, we're going to do a binary search using the current low and the mid as the higher bound. Now let's start converting this into code. I'll just have a function called search, and it'll take in an array, the target, the low, and the high. First, we find the mid by doing mid equals to low plus high minus low divided by 2. And I'm using a double slash here to make sure that the mid is an integer. If you're using C or Java or any other language that you have to declare the type of the variable, you won't need to worry about this. Then we check if mid is the target. So if array at mid is equals to the target, we're just going to return mid. If that's not the case, we'll do an else if array at mid is larger than target. If it is, we're going to return the result from the binary search on the low half. Here we're going to pass in the array, the target, the current low, and the mid minus 1 as the higher bound. Now our last condition. Since it's our last condition, we're just going to do an else condition. If the program comes to this condition, we're going to return the result from the binary search on the higher half. By doing a return, call the search function and pass the current array, target, mid plus 1 as the lower bound and the current high. And before we finish this off, we need a base case to tell the program to stop looping. Our base case for this one is going to be when low is larger than high, or basically when the range is 0. So we're just going to do an if low is larger than high, we're just going to return minus 1 as an indicator that the target is not in the array. And that is actually all for this algorithm. Let's test this out. This here should return 2 because 3 is at index 2. And this here should return minus 1 as a not found indication. Now let's run this. And here we go. The time complexity for this algorithm is an O log n. However, the downside of this is it requires the array to be sorted, and it has to be a list or an array. And that's it for this video, guys. If you like this video, check out this playlist of basic algorithms that I've created. If you find this video helpful, do share it with your friends. It will help my channel out a lot. See you again next time. Bye!